Howdy PreCal, it is Miss Kosh. We are finishing the notes on graphing polynomials. And so I just went through all of this glorious material. Isn't that thrilling? So go find that video if you need that. And now we're going to talk about if I've been given the root of a polynomial, how do I write the equation? I didn't write these notes, I tweaked them a little bit, but I would call this, they call it in root form, so I'm calling that factored form. I assume that that's what they mean. Okay, it says assume the leading coefficient is 1. I'm going to make a distinction too. I want factored form with rational numbers. Okay, so in a second we're going to see this root 3, which is irrational. So we're going to clean that up so that we're not left with that. And then I also see this plus or minus 3i. And that is not only is it not rational, it's not real. So we're going to leave it in factored form. We're going to keep a coefficient of 1, but we're going to clean it up so that we don't have anything irrational or non-real. Okay, so on this first one, we have our polynomial f of x can equal, well, we're just going to subtract away the roots. I'm going to write this x minus 0 this first time and then probably never again. And so I see an x plus 1/2 times, maybe I could put the x out front, I don't have to, times an x minus 3. That to me is factored form. That has a leading coefficient of 1. We could keep foiling it. It's just going to be a little gross. Yeah, we're done. I'm happy with that. Okay, so the next one I have, let's call it a new letter. Let's call this one g of x, just because we're feeling wild and crazy. Yeah, I'm sorry, I need to get out more. Okay, and then I'm just going to subtract all my roots, and I have a leading coefficient of 1. And we're done. Okay, now it gets a little bit more interesting. Okay, so with this one, I have a great way to convert this back into the quadratic it came from. Okay, and so, you know what, I'm going to change, I don't know if I'm going to change one of these when I teach it. Okay, so I'm teaching this in a couple days, so I'll try and remember to do that. I'm going to change it to 1 plus or minus root 3 because it's a little different. I'll leave this one alone. Okay, so on this one, I'm going to take x and I'm going to set it equal to this plus or minus 3i. And when I have the irrational or the non-real part by itself, which in this case it already is, there wasn't any, which is why also I'm changing the second example. What I'm going to do is I'm going to come along and square both sides. Keep in mind, if I have a positive and I square it, it's still positive. If I have a negative value and I square it, it becomes positive. So I am now at x squared is equal to 9, 3 squared is 9, and I squared is I squared. That was ridiculous. Okay, and so I squared, hopefully you know that to be equal to negative 1. And so I end up with this x squared is equal to negative 9. Let's solve this for 0. So I'm going to add 9 to both sides. And this is the quadratic that had the solutions right here. Okay, so now I want this in factored form. I think I had an F and a G. Let's call this a K because that's our favorite letter. And then I have an x minus 0. I don't need the minus 0. Then I have an x squared plus 9. And that is how I'd like to see that answer. Okay, the next one, we're going to start by manipulating this piece right here. And I changed it on purpose because it was too easy and I wanted to make sure I showed you both examples. So we're going to start here. X is equal to 1 plus or minus root 3. And now I only want this irrational part by itself. So I have to move that 1 over by subtracting it. And now I can square both sides. And when I do, I get x squared minus 2x plus 1. Remember, this is an a minus b quantity squared, which we know is a squared minus 2ab plus b squared. If that was too fast for you, go back to some of my previous videos. Okay, once again, plus or minus squared is just positive, and then square root of 3 squared just becomes 3. Now I want to set this one, I want to subtract 3, so this becomes a negative 2, set that equal to 0, and now that is the quadratic. This quadratic right here has these two solutions. Okay, so let's call this one, what did we know? Let's call it P. Seems like a good name for a polynomial. X plus 3 times an x minus 2/3. And then what was this quadratic part? It was x squared minus 2x minus 2. Okay, I'd be perfectly happy with an answer like that. So we can keep, you know what, sometimes I want you to expand things completely, and this one wouldn't be so bad to expand. Is that true? You know what, it's not worth the time. I'll show you, maybe I'll show you if I like one of these two problems. Okay, I see an x equals -1 and with a bounce. I see, see what I'm talking about right here? And then I see an x, excuse me, I see an x equals 0, and I see an x equals 2 with a bounce. And so this, did they give me any other directions? Write an equation in factored form, assume the leading coefficient is 1. Okay. So then I have, we're back to f of x is equal to, I see an x plus 1, this bounce, could be a 2, could be a 4, could be a 6, could be an 8, etc. I'm going to assume the smallest that it can be, okay? Partly because it just gets annoying as the bigger it gets. The more difficult the problem is to work with. And if they wanted it to be bigger than 2, they would have to tell you. They'd have to give you some sort of information. X minus 2, this had a bounce also, so it's squared. Cool. I'm happy with that. Okay, the next one, what do I see? I see a 0 here at -2. It's passing through. I see a 0 at 0, and I think this is at +2 with a bounce. See what I'm trying to write there? Okay, so let's call this one g of x. I see, what did I say? An x at +2 would be the -2. We're passing through 0. We are bouncing at +2, so we have an x minus 2 quantity squared. Cool. Okay, I like this, but I'm not sure that it's good for the video. It's a nice little matching. We'll probably have a chance to practice that in class. Okay, I'll do these last two, but if you're curious about this a little bit, well, I don't know. There's the 6 graphs, there's the 6 equations. Take a screenshot right here and try and figure it out. Okay. Sketch a cubic graph with 3 real zeros. That means 3 real zeros. It's doesn't have any imaginary solutions. And then it says 2 different x-intercepts. Oh, and a negative leading coefficient. Okay, so what that means is we're going to have 2 zeros somewhere, and a negative leading coefficient means that we're going to have to come from the top up here somewhere and end up going down here somewhere. Okay, because it only hits the x-axis in 2 places, it's going to have to bounce at one of them. It doesn't matter which one. I could bounce here just because I found that easier to do. And that's done. Okay, sketch 2 different examples. Oh, look at me being mean and nasty. I'm not a nice person. Sketch 2 different examples of a quartic with 4 real zeros, 2 different x-intercepts, and a positive leading coefficient. Okay, so we just have 2, I mean, and they could both be positive. That gets a little cluttered. Let's make one of them negative. Where they are doesn't matter. And then, okay, so it's got a positive leading coefficient. That means it's going to come from here and end there. And then, so it's going to have to, but it has 2 real zeros. So one, it's quartic. So it's going to have to bounce, or it's going to have to bend, then turn around and pass through. When I kind of miss the point, I just like to make the point bigger. Okay, I think that kind of looks obvious that it's a bend or a wiggle, but if I'm not sure, I'm going to write it down. Okay, that finishes our notes on graphing polynomials. So, like, subscribe, comment, and the only way to learn math is to practice. So, go practice. Good luck.